Hello friend, today we are going to study about the finite state automata with output. In this lecture, we will going to study about the Mealy machine and the Mealy machine. Let's begin the lecture. Hope you will understand this lecture. Finite state automata final state. So if we're talking about these two state with the final state, then you have studied about the DFA, NFA, and NFA epsilon. What is the common between all these three? Common between all these three is their acceptability. What is mean acceptability? If the string end at the final state, then you can say that that string is acceptable. So here the any input string is either accepted or it is rejected. So it is a boolean kind of thing, whether you're talking about true, false, or yes, no. But here we are interested in the output. So this is the output function. In this output function, if you're talking about the Moore, so Moore you can say here the output is dependent on the present state only. But if we talk about the Mealy, then we can say the output is dependent on the present state as well as the input symbol, present input symbol also. So let classify it into in more detail. So talk about the Moore machine. According to the definition, it is a six tuple machine where Q is a set of state. This sigma is a input symbol. Delta, big delta is the output alphabet. Then the delta is a transition function, and lambda is an output function, and Q naught is the initial state. Okay. Now here, if you look this, so it is a general transformation, and it is according to the definition of DFA. What is in DFA? The transition function is basically you can write like this. So what is meaning of this? Meaning of this is that if you have present state and present input symbol, you reach to some state. Okay. So if you do this, then apart from this, what is output? Here the output is dependent on the present state. So it show the present state, and in the present state that is the output. So let study in more detail this thing. So if you take an example like this, if let you are talking about the state Q naught and if you look very carefully, it is so that it is a transition between Q cross input, you are reaching to some state Q. So for example, if I write down Q naught cross 0, you are reaching to some state that is Q1. Okay, so that I write Q naught comma 0 is Q1. Okay, in this way. But what about the output function here? So the output is denoted by the lambda, that is on state Q, and you get something. So here that the output is by look this. Here it is 1. It may be anything. Here it is 1, and let here it is 0. Okay, it is just an example. So here if you look, so lambda Q naught, what output get? 1. Similarly, lambda Q1, what output get? 1. Lambda Q2, what output get? 0. So here it is an output function, and here it is a transition function according to the Moore machine. So here if we move further, let's draw the transition table for this one. So if you make the transition table for this one, it will look like this. So you draw the table. First you write the present state. Then we're talking about the next state, and further you have classified the output, that is a lambda. Okay. So we were talking about the next state. Here the next state is the dependent on some input. Okay. There are two input, 0 and 1. So here you are right on the present state Q naught, it might be Q1, it might be Q2. So if there is a Q naught 0 where you reach Q1, Q naught 1 where you reach Q2, Q1 1 you reach on the same state, Q2 0 you reach on the Q1 0 Q2, and it is 2, Q2 0 is Q2, and Q2 1 is Q naught. Okay, so this is the transition. So here we're talking about the transition of, this is talking about the transition Q cross epsilon is equal to Q. Now what we're talking lambda, the output is of the state Q. Let Q naught. What is the Q naught? 1, Q1 1, and Q2 0. So this is a transition table. So in this way we can represent the transition table for the transition diagram and vice versa. Now next thing is this. According to definition, it is fixed table. What is Q summation big delta transition delta lambda and Q naught. So what is here Q? Q is Q naught, Q1, Q2. Input symbol is 0 and 1. What is input symbol? All these are the input symbols. Sigma, 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 sigma. Delta is a set of output symbol, is again 0 and 1. So here it is, you can say it is a delta, delta, delta. Okay. Now look, transition we have seen here, and initial state is Q naught. So in this way, here is the transition. We are talking about transition, and if you are talking about this, here it is a lambda Q give delta. So all that about the definition of the Moore machine. Let's work on some example. Construct Moore machine for one's complement. If you construct the Moore machine for one's complement, so what should be your approach? So before that, we should understand what is one's complement. If you're talking about the input of one's complement 1010, so the output of one's complement just reverse out this 10, this is okay. So let understood whether this is giving or not. Okay, so for that, just draw this. Suppose you are at any state Q naught, and let me beginning about the 0 because it will be the most significant bit. If you are giving the input 1, the output will be 0. Okay. If you are giving the output 0, you reach to the another state that if you give the input 0, you reach to the another state that output should be 1. Okay. So if you are 0, you continue it here, and if again you get somehow 1, the output should be changed. So this is a one's complement. Take an example. If I take the input, this is the input 1010. What is the output? Output is start with Q naught. So Q naught is here. So the output is 0. Now at Q naught you get the input 1. When you get the input 1, you are still at the Q naught. The output is 0. Then you are Q naught and go to the 0. So if you read the 0, you reach to the Q1. And at the Q1, the output is 1. You are at the Q1, you read the 1. So when you read the 1, you reach to the Q naught. At the Q naught, the output is 0. When you are Q naught, we read the input 0. Then we move to the state Q1. And at Q1, the output is 1 and stop because the input string ended here. So what is the output? This is our output. Here, there is one more thing you can learn. If the size of input is n, the output size is equal to n plus 1 because you are at the beginning you start from some state and that state have already contained the output. So at last you can ignore this, the most significant bit. So here is a more significant bit. You can ignore it here. So you can see here if I pass 1 0 1 0, we get the output 0 0 1 0 1. So that is the machine that giving us some output. So there are more example we will discuss later, but overall concept is this about the Moore machine. Now move on to the Mealy machine. If you look the Mealy machine, it is also a 6-tuple machine, as you can see it here. So Q is a set of state, sigma is the input function, delta is an output alphabet, and this is a transition function is same, but you can see there is a change. And initial state will be same. So what change here you find that the change is this: this output is dependent on the present state while transition with the present input symbol. So here this output is dependent on both the present state and the present input symbol. So at the time of transition, it gives the output. So let's learn with the help of some example. Let one. So if you look this, it is a DFA, and here the transition between Q cross epsilon U reach to some Q. Okay, if you look at here, if you do the transition between Q naught and 1, you reach to some state Q1. What about the lambda? Lambda is saying that it is if you do the transition between Q naught and 1, you get some output. Okay, so here it is represented like this: output is 0 here. This is the output lambda. This is the output. Okay, so if we're talking about this here, so it means you are at Q naught, you are giving the input 1. So what output you get? 0. So let Q naught give the input 1, you get the output 0. So this is a basic difference between the output transition and transition function and output function that you can see it here. Take another example. Let you are at the Q2 and you giving the 1 input. So what is the output? Because the output function here Q2 giving the input this. So this is the Q from the set Q. This is sigma and here it is delta. So you get 0. So in this way we can understood this thing. So what is Q? Q is the same is Q naught set of finite input state Q2 and sigma whatever the this is. So here it is Q, it is sigma. What about the delta, big delta set of symbol 0 and 1? So here it is delta, delta, delta. So all this thing is this. Okay. And rest of the thing is here. It is sigma or come from the sigma, come from the sigma. Okay. Like this. So I hope you understood this. Now how to draw the table. So here we're talking about the table. Let's draw the table. So there is a present state. So present state, next state. In the next state, if you're talking about the input 0, so by this input 0, you will reach some state and generate some output. Similarly, there are two inputs, so we take another input 1. You reach to some state and generate some output. So here it is represented like this: Q naught. Write down the Q1, Q2. If you are Q naught, and input is 0. Here look, input is 0 and the Q naught. Then you reach to Q2. And what output you generated? You generated output 1, like this. If you are Q naught and give the input 1, you reach to the Q2. What output generated? 0. Look at here. You are at the Q naught, input is 1, and output generated 0. Similarly, you can write Q1. Okay. Q1 input is 0, you add the Q1. Okay, and output is 0. Q1 input is 1, you reach to Q2, and the output is 1, like this. Q2 0, you reach to again the same loop Q2, and 0 input, then 0 output. And if Q2 1, Q2 1, you reach to the Q naught. Okay, and Q naught, the output is 0. Okay, so here it is an transition table. Now let's learn this some example also. If we're talking about the example, let's construct the Mealy machine for one's complement. So let's draw this. Here is any state Q naught, and if I will give 1, the output should be 0. If I will get 0, the output should be 1. So here is a machine of one's complement. So if you check with input, okay, suppose you give input 0 1 0 1, so you start from Q naught, there is no output. So when you read at Q naught 0, where you reach to the Q naught. What is the output? Output is 1. Okay, when you are Q naught, you read 1. Where you reach Q naught, what is the output? 1. When you at Q naught, you read 0. Okay, where you reach Q naught, what is the output? 1. Here should be 0. Okay, Q naught, you read 1. Where you reach Q naught, what is the output? 0. So here you can see that if the input size is n, then output size will also be n. So hope you will understood this lecture. Thanks for watching. Have a nice day.